All right, so we're in section 1.6 of Al Grosch's book, Developmental Math 2. We're going to talk about exponents and order of operations now. So an exponent is used to indicate repeated multiplication. And this is what an exponential expression looks like. There's two parts to it. There's the big number, which in this case is 2. We call that the base. And there's a small number in the upper right, which is the exponent. The base is the number that we're going to multiply. The exponent tells us how many of that base we're going to multiply together. So in this case, we read this as 2 to the third power, or 2 cubed. That means we're going to take 3 2's and multiply them together. And you can see that right here when you write it out. 2 times 2 times 2 is 8. It's not 2 times 3. It's 3 2's multiplied together, or 2 times 2 times 2 is 8. So we're going to practice using these exponents. Further down the page here, write each expression using exponents. So the first thing we identify is what number is the base, what's being multiplied, and that would be the 5. And how many of that 5 are being multiplied together, 1, 2, 3, 4. So the exponent is 4. We read this as 5 to the 4th power. On number 2, the base is the number that's being multiplied together. So all of these are -3. So we're going to use parentheses to make sure the negative gets in there with the exponent. And how many are there? 1, 2, 3, 4, 5, 6. So this is -3 to the 6th power. On number 3, we're reading this in words, 14 cubed. 14 is the base, and the word cubed, the same as up here, when I read this as cubed, means the exponent 3. So 14 cubed is 14 with an exponent of 3, or 14 to the 3rd power. All right, on number 4, we actually have two different numbers being multiplied. We have 7's and we have 12. So that means there's two different bases. So we can write them individually. There's a 7 and a 12. Each one will have their own exponent. So how many 7's? There are 3 7's multiplied together, so that's 7 cubed. There are 2 12's. So we say squared. That is 12 squared when the exponent is 2. On number 5, the base is the variable b. The exponent, how many b's are there? 1, 2, 3, 4, 5, 6, 7, 8. So this is b to the 8th. On number 6, there are 3 different bases. The first one being the fraction 4/3. Since there's only one of them, the exponent is 1, but we don't write the exponent 1. When there is no exponent, it's inferred to be there's one of them. The next base is pi, and again, there's only one. The third base is r, and there are 3 r's. So this is 4/3 pi r cubed. Expand each expression and find the value. So expand means to write it out in this form, as in this up here, and then find the value means to actually do the multiplication. If it's reasonable, we'll do the multiplication. So the base here is 3, so that means we've got some 3's being multiplied together. The exponent tells us there are 4 of them, so that's 3 times 3 times 3 times 3. And remember, with multiplication, you can do this in any order. You can group them however you want. So I'm going to group them the way that I think is easiest. 3 times 3 is 9. 3 times 3 is another 9. 9 times 9 is 81. So 3 to the 4th power is 81. On number 2, the base is -2, and there are 3 of them being multiplied together. So -2 times -2 times -2. Remember that rule with the negative signs. If there are an odd number of negatives, this product is going to come out negative. And then we just multiply 2 times 2 times 2. 2 times 2 is 4, times another 2 is 8. So this is 8, not 6, guys. 2 to the 3rd power is 8. -2 to the 3rd power is -8. 7 to the 1 power. The base is 7, The 1 tells us there's just one 7, so that means it's 7. We usually don't write the exponent 1, but if you see it, you know that it just means there's 1, so it's just 7. Negative 1 to the 100th power. All right, we know the base is negative 1. I really don't think we have the time or the space to write out 100 of them, but there will be 100 of them. The key here is how many negative signs will there be? There will be 100 negative signs. So when there's an even number of negative signs, the product comes out positive. When you multiply the numbers, the bases together, 1 times 1 is 1 times 1 is 1 times 1 times 1 times 1, 100 times is going to be 1. So this just comes out to be positive 1. All right, negative 1/2 cubed. The base is negative 1/2, so we have negative 1/2 times negative 1/2 times negative 1/2. Is this going to come out positive or negative? Since there are 3 negatives, that's an odd number, this will come out to be a negative number. And then we just multiply. 1 times 1 times 1. Fractions are top times top times top, bottom times bottom times bottom. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So this is negative 1/8. 0.4 squared. This means there are 2 0.4s multiplied together. So if I write that over here and I multiply them, 4 times 4 is 16. There are 2 decimal places, 1, 2, so I need to move this decimal. This becomes 0.16. All right, down here we have 3 questions that are really similar, but they do have a lot of differences here. Negative 3 squared. All right, so one thing we have to remember with exponents is they are only on what they are right next to. This square, this 2, is only applying to the 3. This negative is not getting the square. All right, it's different from here and also here. This 2 is saying to square the 3. So we know there are 2 3's being multiplied together. This negative sign right here is only popping onto the front. So this comes out to be negative 3 times 3, or negative 9. On number 2, the square is on the parentheses. It's right next to the parentheses, so everything in the parentheses is getting the square. Because that 2 is on the parentheses, it applies to everything in the parentheses. So there are 2 negative 3's being multiplied together this time. So negative 3 times negative 3 equals positive 9. Negative times negative. So the difference here between number 1 and number 2 is the presence of the parentheses and the square being on the parentheses, which means that everything in the parentheses is the base. Looks like I forgot a parenthesis there. Here, the square is only on the 3, so only the 3 is what's being multiplied, and that negative is 1 right in the front. So this one comes out to be positive 9, but this one comes out to be negative 9. What happens here on number 3? Again, the exponent's on the parentheses, so everything in the parentheses is being squared. So that, in this case, that's still just 3 being squared, making the 9 and the negatives in front. So this one also makes negative 9, because this negative isn't just in front. There's only one of them. It's not getting the square. All right, on this next page, we're going to do some order of operations. What are the steps for order of operations? We always work in grouping symbols first, so that would be parentheses, brackets, braces, absolute value bars, square roots, and the fraction bar. These are all grouping symbols that you have to work first. Okay? The fraction bar is actually a symbol for division. It's a grouping symbol because it's telling you to first simplify what's on top, the numerator, and then simplify the denominator and divide at the end. So it is a grouping symbol. It's separating the numerator from the denominator. After we work grouping symbols, then we work any exponents. Then we work multiplication and division. And this is really important here. Multiplication and division are left to right. Always left to right. Multiplication does not always come before division. We work them left to right. Down here, addition, subtraction. If you remember what we talked about in earlier lessons, when you're grouping the negative guys together and the positive guys together, we said there really was no subtraction in algebra. It's all just algebraic addition. You don't have to worry about left to right. If you forget about the subtraction, you just work everything as addition. You don't have to do them left to right. So a lot of people use an acronym for this. I like GEMDAS, which stands for grouping symbols first, then exponents, then multiply, divide, always left to right, and then add, subtract, and you can do them left to right. I like to group them. So I think we got some examples down here we're going to try. Let's see if we can, let's enlarge them here. All right, so if we write on the side, we should be always looking for grouping symbols first. Well, in this example, there are no grouping symbols, so we can skip that step. Then we should be looking for exponents. Well, we do have an exponent right here. So the square is on the 3. 3 squared means 3 times 3, so that would be 9. So I'm only changing the step that I did, the 3 squared, the exponent. Everything else that I haven't done anything with comes straight down. Okay, now multiply, divide. Don't forget it's left to right. We have some multiply right here. 2 times 9 is 18, bringing down this minus 5 because I haven't done anything with it. And then add, subtract. So 18 minus 5 is 13. So this comes out to be 13. Where's example 2? It's down here. Okay, so we're going to use the steps again, looking for grouping symbols first. And this time we have a couple grouping symbols here and here. If you look at this first one here, there's actually no operations inside this grouping symbol. These parentheses are just being used to hold in this negative sign, so there's no operations to do inside this grouping symbol. Same thing here. When we're working grouping symbols, we're talking about doing operations that are actually inside them, and there are no operations in here. This parentheses, again, is just holding in this negative sign. So we can say we're good with grouping symbols. The next step would be exponents. And here we have an exponent right here, don't we? So we have a cube, and that cube is on the parentheses. So we know that everything in that parentheses is going to get cubed. So that's going to be negative 2 times negative 2 times negative 2, which makes negative 8. And then I'm going to pull everything down that I haven't used yet. This is the way you work order of operations. You rewrite everything that you haven't used. All right, after exponents is multiply and divide, left to right. So if you look, here we have a divide right off the bat here. Here we have a multiply. We work them left to right. And in case you didn't recognize it, this is multiply because the number is right next to the parentheses. There's no symbols between this negative 6 and this parenthesis, so this is multiply here. All right, we're going to do this divide first because we work multiply and divide left to right. 160 divided by negative 4. We have a positive divided by a negative, makes a negative. 160 divided by 4 is 40. We're not using this. Well, maybe we will. We'll do this as negative 6 times negative 8. Negative times negative makes positive. This becomes positive. 6 times 8 is 48. And now we're down to the add subtract. Negative 40 guys going up against positive 48 guys. The positive guys are going to win because they have more. These 40 negatives will cancel out 40 of these, so you have the subtraction going on here. And this becomes positive 8. All right, in example 3, still working on order of operations. Start with, are there any grouping symbols? Doesn't look like it. There are no exponents, so we're going to start with multiply and divide, left to right. Here they are. There's a divide here, there's a multiply here. If we work them left to right, we should do the divide first. 100 divided by 2 is 50. 50 times 5 is 250. And then I bring down everything I haven't used. This 250 does come out different if you do these in the wrong order and you do multiply first. If you multiply 2 times 5, you have 10, and 100 divided by 10 is 10. This does not come out to be right if you do them out of order. You have to remember always, multiply and divide, left to right, always. So we're ending here now with what's after multiply and divide? Add and subtract. Or just add if we're talking about it algebraically. So that's what this is. We have 250 minus 12 plus 4. You can do these left to right, might be easier, or you can recognize this is the only negative guy. These two guys are positive. It doesn't really matter. You come out with the same thing. 250 minus 12 is 238, plus 4 is 242. All right, number 4 over here is really starting to get complicated now. First, we're going to work in grouping symbols. And we do have a couple different grouping symbols here. We've got brackets here, and those are the set of brackets there. And we have parentheses inside them. So when we have two sets of grouping symbols, we start inside and we work out. So we're going to start inside these parentheses, and we're going to follow the order of operations inside, which means that we're going to do exponents first inside this parentheses. So we're going to do 8 squared first. Now this square is only on the 8. It's not on the negative. So we're only squaring the 8. So 8 squared is 8 times 8, which is 64. So this parentheses ends up being 4 minus 64. When we add that together, that's negative 60. And I'm going to go ahead and replace everything I haven't used. Just like that. All right, so I've done everything in that parentheses. So now I need to look at these brackets and work inside them. Okay, we have a subtraction slash addition here. And here, this is a multiply because there's no symbols between this 3 and this parentheses. This means a negative 3 times negative 6. So we need to do this multiply before we do this add out here, because multiply, if you remember, multiply divide comes before add subtract. So we need to do this multiply first. So we have negative 3 times negative 60 is going to be positive 180. Then we have this negative 2 here. So we're almost done in these brackets. This is add negative 2 plus 180. Okay, the positive guys are going to win. They're going to have 178. All right, now I'm replacing everything I haven't used. I haven't used this negative 2 out here or this negative 4 out here. What's the next step? What operations do I have left? This is obviously an addition slash subtraction. This is a multiply, again, because this 4 is right next to the brackets. It's multiply. We do multiply before add, so we need to multiply this first. So we're going to have negative 4 times 178 is going to be negative 712. Then we have negative 2. Now we're down to the add part. These are same signs, so they're not going to fight against each other. They're not going to cancel each other out. They're going to group up together because they're on the same side. So this is going to be negative 714. All right, for number 5, we have this fraction bar, which is a grouping symbol. The fraction bar tells us to simplify the entire numerator, simplify the denominator separately, do the division at the end that the fraction bar is indicating. So we'll simplify the numerator first. What do we have here? We have we have parentheses. Well, we need to work inside those parentheses first. I'm going to see, do I have some room? Yes. So, not doing anything with this -3, but in the parentheses, 3 plus 2 is 5. So you can see I'm kind of writing up here because it's convenient when I'm working this multiplication. 3 plus 2 is 5. This is a multiply because the 3 is right next to the parentheses. This is an add. Multiply comes first. So -3 times 5, -15 plus 5. -15 plus 5, these are opposite signs. So when you add them together, this positive is going to cancel out 5 of these negatives. We're going to end up with -10 in the numerator. Now we're going to simplify the denominator. This is multiply, this is add. Multiply comes first. So when I multiply -3 times -4, I get +12. I haven't used the 8 yet. 8 plus 12 is 20. So I end up with -10 over +20. Now I just need to do this division. Well, this is not going to divide out to be a whole number. This is actually a fraction because the numerator is smaller than the denominator. This is a proper fraction. When you end with a proper fraction like this, all you need to do is reduce it. So we're going to reduce this to make -1/2. All right, we have some grouping symbols here. These are not ones, these are the absolute value bars. So those are grouping symbols, so we're going to work inside the absolute value bars first. So 2 minus 5 is -3. The absolute value of -3 is 3 because remember, absolute value means how far is this number from 0. -3 is 3 units away from 0, and I'm going to replace the absolute value bar with parentheses because I don't want to lose this multiplication that's right here. This 10 next to the absolute value means we're going to multiply. So you don't want to lose that. So you just replace them with parentheses. You have a multiply here. You have an exponent here. Exponents come before multiply. So you're going to want to do this first before you do this multiply. This 5 exponent is only on the 2. It's not on the negative because it's not being held in with parentheses. It's only on the 2. So this says there are 2 5s being multiplied, 5 2s being multiplied together, which makes 32. This negative sign coming straight down. Because it's not part of the base, it just comes straight down. And we still have 10 times 3 here. Now we have a multiply and we have an add. So we're going to multiply first. 10 times 3 is 30. Minus 32 leaves us with -2. All right, number 7. Got some absolute value bars here and in the denominator. So we're going to work the numerator first. Got a little bit of room here. Okay. So 4 minus 7 leaves us with -3. And you can see I just carried this negative sign up, carried the absolute value bars. Now I'm going to do the absolute value. The absolute value of -3 is 3. I can replace that with parentheses, but this negative sign is still there. So this is simplified to make -3 in the numerator. In the denominator, the absolute value bar and then the 4 minus 7 makes absolute value of -3. The absolute value of -3 is 3. I don't need the parentheses because there is nothing here on the outside of the absolute value bars. So this just becomes -3 divided by 3, which is -1. All right, this one's really complicated. It looks really confusing at first because there are 3 sets of absolute value bars. There's absolute value here around the 3 squared and the 5. There's absolute value bars here around these 3 numbers. And there's absolute value bars back here around this -3. So we're going to work inside each of them, but we're going to do it all at the same time. Since they're not really connected, they're separated by these plus and minus signs here, we can kind of carry them down individually. So that's what we're going to do. Let's work inside here first. Okay, so when we're talking about a mean, we're talking about an arithmetic average. The word mean means average. We divide the sum of the values by the number of values. So a sum means add. So you have to first add your pieces of data, then you divide that sum by how many pieces of data you have. So if we're going to find an average of these pieces of data, we want to find our average test score here. We made a 90, an 80, a 100, and a 70. First, we have to add those pieces of data. So what does this make when we add it? So this makes 340. Then we divide that sum by the number of values. We had 4 pieces of data here. So we're going to divide the sum, which is the 340, by the 4 pieces of data. What do we get when we do that divide? 4 goes into 34 8 times. That makes 32. Subtract, bring down, 4 goes into 25 times with no leftovers. So it looks like our average test score here is 85.